Hello and welcome to GyaanSarathi. Today we are going to study straight lines. Starting with the definition of straight line. A straight line is defined as the curve which is such that a line segment joining any 2 points on it lies wholly on it. Okay. So if we have 2 points, so a line segment joining these 2 points, okay, this is a straight line. Okay. The general form of equation of a straight line is ax plus by plus c equals to 0. Okay, so this is the general equation of the straight line. In this one, a, b and c belongs to R, and at least one of a and b should be non-zero. If both of them are 0, in this case a comma b, if a comma b both 0, then we get c is equal to 0. Okay, so this does not represent a straight line. Hence at least one of them can be 0 but not both at the same time. Moving ahead, slope or gradient of a line. What do we understand by slope or gradient of a line? Slope is nothing but inclination of a line. Okay, then the tan theta is called the slope or gradient of the line. Here theta is the angle made by the line with the x-axis. So as you can see here, we have x-axis here and y-axis here. Now we consider this line AB. So we see angle AB is making angle theta with the x-axis. So tan theta would be taken as slope. Slope is represented by m, small m. Okay, theta is always measured anti-clockwise. If we measure anti-clockwise, then it is always taken as positive, but if it is measured clockwise, it is taken as negative. So we see here there are angle made by this line AB with the x-axis in the clockwise and the anti-clockwise direction. So in the anti-clockwise sense, the angle made with the x-axis is theta, but in the clockwise sense, the angle made by the line AB is pi minus theta. So when we consider the anti-clockwise angle, we get tan theta, which gives us the slope of the line AB. But when we consider the clockwise sense and we consider the angle pi minus theta, we have tan of minus pi minus theta. Why? Because as already explained, if we are taking clockwise, we have to, that angle is taken as negative. So pi minus theta, a negative sign will come here. So then this tan minus pi minus theta becomes, this thing becomes minus of tan pi minus theta. Okay, and tan pi minus theta is minus tan theta, and minus is already outside, so this becomes tan theta. Okay, so which eventually gives us the slope of the line AB, that is equal to m. So hence we conclude that when we are talking of the slope of a line, we do not take into consideration the direction of the line segment. Okay, so if we are measuring the slope in the anti-clockwise sense or clockwise sense, does not matter, the slope is coming out to be same. So in the clockwise sense, the line direction of the line was taken as AB, but in the anti-clockwise sense, the line direction was taken as AB. In the clockwise sense, it was taken as BA. So it does not matter when we talk about the slope, we do not take into consideration the slope, the direction of the line segment. Moving ahead, now here we see how to find the slope of a line when 2 points are given on the line. So this is the line AQ, Okay, and we have taken 2 points on this line, that is P and Q. P is x1 y1 and Q is x2 y2. Okay, so the slope of the line is given by y2 minus y1 by x2 minus x1. Now let us see how we came to this conclusion that the slope m is equal to y2 minus y1 upon x2 minus x1. So in this line, on this line, when we see, we consider the triangle PNQ. Angle QPN is also theta because because the angle made by the line to the x-axis is theta. So this angle QAM, I can write angle QAM is equal to angle QPN. Sorry, this is QPN. Okay, now we see QM is equal to y2 and PL, as you can see in the figure, is equal to y1. So again this part is x2, as you can see in the figure. Let this be the origin, let us name it O. So OM is equal to x2 and OL is equal to x1. Okay, so in the triangle QPN, when I find tan theta, I get tan theta is equal to perpendicular, that is Q1 upon Pn. Now let us see from the figure here, Qn is equal to what? Qn is equal to Qm minus PL, I can write it, which is equal to y2 minus y1, right? Now I need to find Pn. So Pn, I can write it as Lm. Pn is equal to Lm, which is equal to OM minus OL, and this is equal to x2 minus x1. Hence, substituting this value, we get tan theta is equal to y2 minus y1 upon x2 minus x1. Now, as we studied earlier, tan theta is nothing but the slope. So this represents the slope of the line. So if you have 2 points on the line, that is x1 y1 and x2 y2, then the slope of the line is given by y2 minus y1 by x2 minus x1. Moving ahead, slope of a line is the tangent of the inclination of the line. Okay, so that is what we have studied in the last page as well, that slope of a line is nothing but tangent of the inclination of the line, that is tan theta. Okay, now if a line is parallel to x-axis, then its slope is equal to 0, because in case if a line is parallel to x-axis, the angle made by the line with the x-axis is 0, therefore tan of 0 is equal to 0. Slope of a line parallel to y-axis and perpendicular to x-axis is not defined. Perpendicular to x-axis, it means the line is making an angle of 90 degree with the x-axis, and in that case tan 90 would be the slope of the line, which is not defined. If two lines are parallel, then their slopes are equal. Okay, if two lines are perpendicular, then the product of their slopes is -1. For these two, I am not suggesting any proof right now, we will see it in the upcoming slides. If 3 points A, B, C are collinear, then slope of AB is equal to slope of BC is equal to slope of AC. This is understood as, if I draw 3 points which are collinear, it means we are talking about only one line only. So if we talk about slope of any, considering any 2 points on the line, then the slope will always be equal. Moving ahead, we have a question. For what value of k the points k comma 2 minus 2k minus k plus 1 comma 2k and minus 4 minus k comma 6 minus 2k are collinear? The options are 1, minus 1, 1 by 2 and 2. Let us see how to solve this question. So we have been given 3 points, that is, we assumed let A to be k comma 2 minus 2k and B to be minus k plus 1 comma 2k and C to be minus 4 minus k comma 6 minus 2k. Okay, and as mentioned, they are collinear. Now slope of AB will be equal to slope of AC. Okay, we just saw that because we are talking about the same line, so the slope won't vary. So how, in this case, how are we finding the slope of AB? We are using the formula y2 minus y1 by x2 minus x1. Okay, so AB I am writing the slope as 2k minus 2 minus 2k upon minus k plus 1 minus k, and AC the slope I am writing it as 6 minus 2k minus 2 minus 2k upon minus 4 minus k minus k. So solving this, it becomes 4k minus 2 upon minus 2k plus 1, and this becomes 4 upon minus 4 minus 2k. Then doing cross multiplication, 4k minus 2 into minus 4 minus 2k and 4 into minus 2k plus 1. Okay, so from here I have taken 2 common from the first bracket. It becomes 2 into 2k minus 1 into minus 4 minus 2k is equal to, I have taken minus common from the bracket on the RHS, and this becomes minus 4 into 2k minus 1. Okay, so now this becomes 2 into 2k minus 1, this becomes minus 4 minus 2k, and this, the term on the RHS, I brought it to the LHS, so I can write it as plus 4 into 2k minus 1 equals to 0. Now taking 2k minus 1 from the both the terms common, this becomes multiplying 2 with the minus 4 and minus 2k, so this becomes minus 8 minus 4k plus the term left here, that was 4. Okay, so I get 2k minus 1 into minus 4 minus 4k. So either 2k minus 1 is equal to 0 or minus 4 minus k is equal to 0. So from here I get k is equal to 1 by 2 and k is equal to minus 1. Now I cannot take k is equal to 1 by 2 because in that case the slope of AB won't be defined. Here see, in the denominator of AB, the slope of AB, we have minus 2k plus 1. If I put k is equal to 1 by 2, this becomes 0. So the slope of AB won't be defined. Also we see, if we put k is equal to 1 by 2, our points A and B coincide. Okay, so we neglect k is equal to 1 by 2, hence k is equal to minus 1 is the correct answer. Okay, I hope you understood the solution. Moving ahead, now we are talking about angle between two lines. So the acute angle between two lines, theta is having slopes m1 and m2 is given by theta is tan inverse m2 minus m1 upon 1 plus m1 m2 modulus. Okay, so let us understand this. How do we get this formula or this result here? That is, theta is tan inverse m2 minus m1 upon 1 plus m1 m2 modulus. So let us consider a case here, that is two lines L1 and L2. As you can see here in the figure, this is L1 and this is L2. So we have two lines L1 and L2 which be two non-vertical lines, means non-vertical as in they are not making 90 degree with the x-axis. Okay, and the slopes of the respective lines are m1 and m2. Theta 1 and theta 2 be the inclination of the lines L1 and L2 respectively, as you can see here, theta 1 and theta 2 in the figure. Okay, so now we see the angle between the two lines is theta. Otherwise we can say the angle between the two lines is pi minus theta as well. So this is the acute angle between the two lines. Okay, as we can see from the figure itself, and this is the obtuse angle between the two lines. Now we have m1 is equal to tan theta 1 and m2 is equal to tan theta 2. Let us move back to, in the figure we saw theta 2 is equal to theta 1 plus theta. So theta will be equal to theta 2 minus theta 1. Okay, so tan theta is equal to tan of theta 2 minus theta 1. So using the formula of tan A minus B, so let me write it here, tan A minus B is equal to tan A minus tan B upon 1 plus tan A tan B. So this formula is used. So I have written tan theta 2 minus theta 1 as tan theta 2 minus tan theta 1 upon 1 plus tan theta 2 into tan theta 1. So tan theta is equal to tan theta 2 is m2 and tan theta 1 is m1. So m2 minus m1 upon 1 plus m1 m2. Okay. Now the other angle, that is the obtuse angle made between the two lines, was pi minus theta. So tan pi minus theta is minus tan theta, that would be minus of m2 minus m1 upon 1 plus m2 m1. So tan theta is equal to plus minus m2 m1, m2 minus m1 upon 1 plus m1 m2. Okay, so theta would be tan inverse plus minus m2 minus m1 upon 1 plus m1 m2. Hence the acute angle, if I am asking, between the two lines L1 and L2 is given by this formula, that is theta is tan inverse m2 minus m1 upon 1 plus m1 m2, and we are taking modulus as in we do not know whether the result will be positive or negative. So but we know that the angle theta is acute, so tan of that should come out as positive. Therefore we are putting a mod to get the acute angle between the two lines L1 and L2. Now in the case if two lines are parallel, the angle between the two lines will be 0. So tan theta would be 0. In that case, this thing m2 minus m1 upon 1 plus m1 m2 should be 0. So that is only possible when the numerator is 0, that is m2 minus m1 is equal to 0, that is m2 is equal to m1. As we had seen in one of the points in the previous slide, that when two lines are parallel the slopes are equal. So we understood the reason from here why the slopes are equal. Now if the two lines are perpendicular, the product of their slopes is minus 1. So if the two lines are perpendicular, that is tan theta should be equal to tan 90 degree. That means not defined. This case the thing would be not defined only when the denominator is 0. In that case m1 plus m2 m1 is equal to 0. Hence m2 m1 should be equal to minus 1. Okay, so I hope we understood how the product of the slope is minus 1 if the two lines are perpendicular. Moving ahead, we have a Question from JEE Mains 12 January 2019 shift 1. The question says if the straight line 2x minus 3y plus 17 is equal to 0 is perpendicular to the line passing through the points 7, 17 and 15, beta, then the value of beta is A 35 by 3, B minus 5, C minus 35 by 3 and D 5. Let us see how to solve this question. So we have the equation of the line 2x minus 3y plus 17 is equal to 0. This can be written as y is equal to 2 by 3x plus 17 by 3. Let me explain it here how I wrote this. So this is 2x minus 3y plus 17 equal to 0. In this one I have taken 2x plus 17 on the LHS and sent 3y to the other side. So y is equal to 2 by 3x plus 17 by 3. Okay, now this is of the form y is equal to mx plus c. Okay, slope intercept form. So here m represents the slope of the line. So from here I can find that slope of the straight line is 2 by 3. Now for the slope of the line passing through the points 7, 17 and 15, beta, we are using the formula y2 minus y1 upon x2 minus x1. Okay, so that would be beta minus 17 by 15 minus 7, that is beta minus 17 by 8. Now the two lines are perpendicular, so m1 into m2 should be equal to minus 1. So 2 by 3 into beta minus 17 by 8 is equal to minus 1. Solving this, we get beta is equal to 5. Okay, so option D is correct. Moving ahead. So equation of a line parallel to y-axis is x equals to a. We can realize this. If we draw this is the x-axis, this is the y-axis. Now if I draw a line parallel to y-axis, that would be like this. If this is point A, then the equation of this line will be x equals to a, because at every point on this line the value of x remains constant, that is x is equal to a. Okay, similarly equation of a line parallel to x-axis is y is equal to b. Now if we consider a line like this, if this is point B, so this equation of this line will be y is equal to b, because at every point on the line the value of y would be b. Okay, so if a line cuts x-axis at a, 0, you can see there here in this figure, this line AB is cutting x-axis at a, 0 and y-axis at 0, b. Okay, then OA and OB are known as the intercepts on the line x-axis and the y-axis respectively. So OA, as you can see here in the diagram, is called as the x-intercept, and OB, as you can see here in the diagram, is called the y-intercept. Okay, modulus A is called the length of the intercept on the x-axis. So this length is A, as we can see in the diagram. This is called the length of the x-intercept, and this length is B. Modulus B is called as the length of the intercept on the y-axis. Okay, intercept of a line on the axis may be positive or negative. Here in this case they are positive because the line is cutting the positive x-axis and the positive y-axis. If it is in the second quadrant, then you have x-intercept to be negative, y-intercept to be positive. If in the third quadrant, then you have both of the intercepts to be negative, and in the fourth quadrant, y-intercept negative, x-intercept positive. Okay, so if a line is parallel to y-axis, then its intercept on the y-axis is not defined, and if line is parallel to x-axis, then its intercept on the x-axis is not defined. Pretty obvious, as you can see here in this one, this line x equal to a is not making any intercept on the y-axis, hence there is no intercept on the y-axis defined, and this line y is equal to b is not making any intercept on the x-axis, so the intercept on the x-axis is not defined. I hope you understood. So that is all for today. Thank you.